Hello everybody, my name is Rosado and I'm a professor at the Lisbon School of Architecture of the University of Lisbon. The other author of this paper is Jorge Tavares Ribeiro. He's a professor at the Lisbon School of Architecture and a researcher of the Natural Resources and Environmental Research Center, both from University of Lisbon. This work is about the use of information and communication technology techniques in mathematics, higher education, teaching, and learning. The idea is to assess if the techniques used for teaching mathematics to our BSc students of architecture and urbanism are really effective. As we all know, reading, mathematics, and science knowledge and skills are fundamental to meet real-life challenges. And as the PISA report stated from 2016, more than ever, students need to engage with mathematical concepts. They have to think quantitatively and analytically, and have to communicate using mathematics, and have to learn how to do this and to experience the importance of doing this, as everybody will learn better what they are trying to explain. More than the knowledge of mathematics, this must be a daily and professional tool in areas such as architecture and urbanism. It must be an integral part of the way in which the world is seen and interpreted in order to be able to create in full harmony with the laws that rule the universe. About the architecture and urbanism courses in some European universities, as mathematics is concerned, in most European universities, there is mathematics in the course of architecture and urbanism, such as our university, University of Lisbon, Architecture School, the University of Madrid, the University of Barcelona, the University of Bologna, the University of Rome in Italy, and without mathematics, there's, for example, two universities in Portugal that don't have these contents in their course directly. The main goal of teaching mathematics in courses like architecture and urbanism is to develop a critical and methodical spirit in the approach of the problems and to implement rationality and dexterity in its resolution. The approach of the problem to find out solutions about it, it's much simpler if you have a systematic approach, if you have a method, and mathematics helps you a lot with that. And even if the students will rarely use the learned calculus in their lives directly, it has an inexorable role in their scientific evolution and training. These skills, developed by the methodical study that mathematics requires, provide the ability to, in everyday life, be better prepared to face and analyze problems, facilitating decision-making that requires systematic reflections, both in the professional field and in the personal field. Mathematics can be considered a fundamental instrument to understand the space in which we live in. And in arts, in courses like architecture, it helps you to be much more objective in the approaches of the situations you are going to evolve. The first influence of mathematics on architecture was perhaps of Pythagoras. For Pythagoras, everything were numbers. The number was the synonym of harmony, the essence of everything. For this Greek philosopher and mathematician, and for the Pythagoreans, the number had a religious meaning. The Pythagoreans believed that all things are numbers, clearly had great significance for architecture. Geometry was the study of shapes for them, and shapes were determined by numbers. So, numbers are the essence of everything. Some examples that illustrate how relatively simple it is to demonstrate how fundamental mathematics is in the art of creating. For example, the Colosseum in Rome, Italy, with its round shapes, its monumental size, Diana's Temple in Portugal, in Évora, the Calatavas Bridge, defying all the physics rules, the Rome Pantheon in Italy, and so on. So many examples. Another example that shows us how the mathematical fundamental concepts are present in the art of creating and about the scaling of things is the Gulliver's Travels by Jonathan Swift. We have here some images that show us the importance of the scale and how the scale determines the architecture, the buildings you have to construct and you have to create. So it is necessary for students to discover that mathematical tools are particularly adaptable to describe forms found in architecture and in art. They should be encouraged to read the shapes mathematically and learn the theory fundamental to this goal. It is obvious that they will understand by themselves that mathematics, with its rules, is not in opposition to their thoughts, but on the contrary, provides them with a real and effective support to become more creative. Once again, mathematics helps the approach to the problems, helps to be able to be very objective about what you're trying to create, what kind of approach you want to do to your problem. The noblest aspect of the contribution of mathematics to education through art is in the disciplined habits of thought, of problem solving, through the desire to reach an elegant rational solution to a problem, and this elegance can be precisely the link between mathematics and architecture. Worldwide famous Portuguese architect César Vieira gave in an interview his perspective of mathematics, and he said that what I feel I learned with learning mathematics from the architecture course was the habits of reasoning and the clarity of ideas. When I'm conceiving a project, I have a great fascination for relationship between the measurement numbers and find order from there. For example, when having to decide the measure of a room, I choose a multiple to the greatest measure. Here are some examples of works made by César Vieira. Parque das Nações de Portugal Pavilion in Portugal, the Art Museum in Porto Alegre, Brazil, and this curvilinear building located over a lake in the city of Jiangsu in China. So about our students in the Lisbon School of Architecture, our BSc students, the mathematics background that they have when they get to our university. We have 37% of students that had mathematics just until the 9th grade, 35.96% of students having mathematics for sciences until the 12th grade before going to college. Another kind of mathematics applied for arts, 16.67% have that kind of mathematics, and other 9%. Okay, so the majority had mathematics until the 9th grade or mathematics for sciences, which is the most difficult one. It's a broad range of knowledge of mathematics in our students. So we made an inquiry to our students about the teaching and learning in mathematics for architects and urbanists. And the idea was to understand if the information and communication technology techniques that we were using in class was getting there, was being useful for students. And so we made all these questions. For example, how do you evaluate the contents of the mathematical course? How do you evaluate the existence of examples of architecture related to the topics taught? How do you evaluate the slides available as study elements? How do you evaluate the interactive games done in class concerning the contents taught? How do you evaluate the interactive games done in class in terms of relevance to your learning, realizing where you have difficulties? How do you evaluate interactive games done in class in terms of usefulness to better understand the concepts? How do you evaluate the contribution of this subject to the development of your abstract reasoning? How do you evaluate the contribution of this subject to solving problems that have arisen in other subjects? And how do you evaluate the contribution of this discipline in your daily life? So we used the Likert scale, and we made this inquiry available on internet, and they responded in their phones or in their computers after class. Concerning trigonometry, these are some of the examples we gave about the relevance of the relation between angles and triangles in some architectural buildings, and an illustration of the Pythagoras theorem. Okay. About functions, we had some examples also about the sun trajectory, about the San Francisco Bridge and Lisbon Bridge, with the example of the parabola, the sound reflection, parabolic sound reflection in the Capitolio, for example, in USA. We have some examples about this. The interactive game that we wanted to assess in our inquiry was Kahoot. We made 10 questions with multiple choice answer. This is the aspect of Kahoot. We have a question, you have your phone as an answer command, and you had to time, for example, this question has 20 seconds to answer, and you just had to understand the question about the topics taught in class and answer to assess if you understood the concepts, what are your difficulties. And then in the inquiry, we were supposed to understand if this was getting the results we were expecting. That's why we wanted students to evaluate if the interactive games are helping them to understand the concepts, and if the architecture examples are helping them to understand the use of mathematics in these courses. So about the results of the inquiry, when we were evaluating the contents of the mathematical course, we can see that 82% more or less think that it's easy or very easy, as we understand that most of our students were having mathematics until the 12th grade. Okay, so the concepts are not very difficult, and as we have a broad range of students with different knowledge of mathematics, we don't make it very difficult so that they are able to understand the concepts we're giving. About evaluation concerning the lectures of mathematics, we had 3 questions about the examples of architecture given in class, and here we have 30% saying that it's excellent, and almost 50% think that it's in scale 3, so almost excellent. It's a good result about the examples of architecture. Then about the slides we give in class as a support for studying. 60% say they're excellent, so the slides we gave help them to study and to understand the concepts. And about the interactive games, in terms of contents, 42% say it's excellent, and almost 80% say it's a 3 or a 4 in a scale of 4. Okay, some classes we weren't able to make the interactive games because of having no Wi-Fi or some technical problems sometimes. So that's why 14% say that it's not applicable, the question. The evaluation results concerning the interactive games made during class. Once again, sometimes we weren't able to do it, so we have 14%, 15% that didn't answer, say it's not applicable, but the other ones about concerning the interactive games to understand if they were useful to assess difficulties and if they were useful to better understand the contents about mathematics taught. To assess difficulties, 28% said it was very relevant, 35% said it's a 3 out of 4, so we should continue on doing this because even if they didn't study a lot when they are doing those interactive games, it helps them to assess difficulties. And about being useful to better understand the concepts, so we have 50%, 60% think that it's relevant. So these are results that show us that these techniques are useful to help students to understand the mathematical concepts. So the final questions were about a more broad range of results. We wanted to understand the contributions of this subject to develop the abstract thinking and the abstract reasoning, if it helped to solve problems in other subjects, in these courses of architecture and urbanism, and in their daily lives. We were very pleased with results as to develop the abstract thinking. 44% said it's a 3 out of 4, 23% said it's an excellent development, the abstract thinking, so very good results, almost 70% made the goal we wanted. About helping to solve problems in other subjects, it's okay also, almost 60% said it was excellent or a very sufficient help for solving problems in other subjects. About the daily life, 29%, 30% was a 3 out of 4, and 14% said it's excellent in their daily lives. We also give examples about how mathematics helps in daily life, and so probably that's why they understood that it would help them, and they were more sensible in their daily lives about it. So as a conclusion of this work, I think we can say that the communication and information technology techniques that we used in our classes were very useful for our students. The feedback we had is that it helped them for their abstract thinking and reasoning. It helps in solving problems in other subjects. So it's been very useful, and we're going to continue on doing it. And we advise everyone to do this. Students realize the importance of mathematics for developing a critical and methodical spirit in the approach of the problems and to implement rationality and dexterity in its resolution. Information and communication technology is very useful in teaching and learning mathematics in higher education, and it helps to understand the application of the concepts in a more easy way and adapt it to the generations of today. So thank you very much for your attention, and we hope that this work was interesting for you and these results help you to implement some of these technologies in your classes.